Alright, so this must be the heaviest package I have ever received. 50 fucking kilograms. Alright. Let's open it. Jeez. Alright. So this is professionally done because I know the guy who sold these things, and he uses Instapack. Those are very nice packaging stuff. There's a foam, they inject the foam inside and it actually expands and makes a very, very good packaging material. Alright, so this is the first one. It actually lost something from the back, I don't know. This is a this is a function generator. I got this thing for, I think, just over 30 euros. Must be pretty good. It's a synthesizer type. I didn't expect. Alright, so this is the first power supply that I got to replace the other two that I actually sold. This must be the 60 volts 1.5 amps. I didn't expect that. I expected something much smaller kind of thing, but alright, so I have another one. This is another one. This is a 20 volts 3 amps, and there is something rattling inside. I mean, I picked this up for 20 euros, so I'm not really concerned about that. And those power supplies are modular, by the way. So I picked up the rack mount case. There's something rattling inside, but anyway, this is a Rakaldana digital multimeter. It's a, I think it's a 5.5 digits multimeter. It's a very, very high resolution voltage meter. Holy shit, man! We have two modules here, two power supplies. There are two 10 volts. Oh, 10 amps. Oh, jeez. I suppose those are actually 10 volts, 8 amps power supplies with a. Well, I don't really know what's this. It's a interface bus. I think it's a GPIB power supply. But anyway, so I picked up this whole thing just because there was the rack mount case. I just needed the rack mount case for it. So those are not working condition. Everything here is not working condition. At least that's what's he said. It's a standard 19 inches rack unit. There are no flanges here, so they're missing. So here we go. Let's actually remove those. Alright. This must be a switching power supply unit. So yeah, I don't really love switching power supplies. But anyway, one is out, and let's take the other out as well. And just slide out without any problem. There we go. Alright, very nice. And this is an identical unit. I don't know. What is this? Oh, we have some surprise in it. We have a ground terminal flying around here. They just covered the terminal, the connector, with some plastic bag, which is quite funky. Pretty good. Alright, so this is the GPIB interface. We have some boards in it. So yeah, I'm gonna clean it because it's very, very dirty and crusty inside, so yeah, I might actually get a good clean. Let me get this out of the way and get the two power supplies. Alright, so we have the first one here. Before actually powering it up, and try to see if it actually works. Let's actually, the first thing to do is get a multimeter, go to ohms range and measure the input, the actual mains socket here, because if there is a short, you're gonna actually blow up your fuse on your house. So yeah, it's not a good thing. Just it's a couple of seconds. You're gonna measure between the two poles and see if there is anything wrong. I see, obviously make sure it's on position, and I see 1.8 climbing. So obviously this is a switching power supply, so there's no direct connection. If it was a linear power supply with a big transformer, you would actually see a fixed impedance and will be actually pretty low. But in this case we have a bridge rectifier and a capacitor most likely, so this should be actually correct. So let's actually measure between one pole and earth, so there should not be anything here, and we have a capacitor here, and that's expected, and we have a capacitor also on the other side, so that's expected. One last thing is make sure the case is properly earthed. So this case, it's earthed, so we are totally fine. Alright, so I plug it in and let's find out if it works or not. I might actually end up being a total crap, or we should actually hopefully the magic smoke will not escape, or it doesn't explode, hopefully, so finger crossed. Alright, so we have some life, and but we have no relation, no nothing. Right, so voltage doesn't work, amps doesn't work. Let's see if there's something else. We have some voltage here. If we increase it, holy shit! All right, all right. So magic smoke escaped from the main side. All right, so that's this smell. Jeez, wow! Look at the smoke. Look at that. That is beautiful. Magic smoke. Best thing ever. Alright, so magic smoke escaped. I was not completely unprepared. I had my safety switch here that is very useful. So here we have the power supply, and I saw the smoke coming out from here. So I see a dead input capacitor, mains capacitor. They actually fail rather nicely. Alright, so we can actually see the construction here. It is pretty messy, and this is the capacitor that exploded. It's the main filtering capacitor here. Alright, so I think I did a decent job rebuilding this thing, and hopefully it doesn't explode. Alright, seems working.
And yeah, it's pretty much spot on. That's very interesting. 4 volts, 6, 8, all the way to 10 volts.
One thing though, it does not go to 0. It's stuck at 1 volts. It's the minimum, probably because they have no circuitry for going all the way to 0. This thing actually regulates current and voltage by varying the PWM of the switching transformer. But anyway, I tested it and I took it on the load, and this thing is just fine.
Alright, so we have the 20 volt 3 amps unit. I've already measured the impedance here and it should be alright. So switch it on. Alright, it lights up. 7 volts is perfect. Let's get to 10 volts. Yeah, pretty close. 15, pretty close. 20 volts, it's the maximum. Yeah, it actually is perfectly working. Let's go to amps again. 2 amps. Perfect. Alright, so since I have to clean those, I might just go and disassemble the units and see what's inside. So let's go. Right, so this is the front panel, and we have some circuitry over there. It's actually quite cute. I mean, look at that. There's a little meter here and the 2 potentiometers and a bunch of TO6 transistors for, I think it's just for the meter movement. And this little thing here, by the looks of it, seems like a thermal switch or some sort. So I think that if it actually reaches a certain temperature, it bends, so it no longer makes contact with this piece here. It's a very interesting one. I've never seen one of those. And I think I have to change some capacitor, this one for sure. I mean, look at that, it's all cracked and yeah, it's not in really good shape. Alright, so now I'm gonna actually clean this thing and change some capacitor maybe. Alright, so I'm just reassembling the unit, and I'm gonna put a little piece of paper here to prevent the board from shorting out to the outer case, because it was pretty, it is actually pretty close. And the last bit is this GPIB power supply here. I don't really know. This is an interface for GPIB. So this is the inside, and I've already taken a little board out. Has some power supply stuff happening here, some regulators by the looks of it. I think this is the main processor. It's a EF 6C821P from 84. Some other miscellaneous stuff. So yeah, I don't know what's its purpose, and I try to power it up and it powers up, but that's as far as I can actually go, so I don't really know what to do with it. Alright, so the first 2 are in and are secured, and I left a space here for the other 10 volts 8 amps power supply that hopefully I'm gonna fix, and I left another space here for the 60 volts 1.5 amps power supply. That doesn't work anymore. Alright, so I continued the testing of the power supplies that I got here, and unfortunately I found out that 3 of 4 of them are not really working properly. So yeah, I'm gonna do another video on troubleshooting and fixing, hopefully, linear and switching power supply, which is gonna be, I think, quite interesting. So, I'm gonna end up this video here. So as always, thanks for watching, and I'll see you next time. Bye!